Oh boy, this lesson, I'll tell you, over the years has gotten to me. So here's my thought on this. Take notes. Make sure you have these notes available. This is all review of stuff that you guys did in junior high school. So make sure you know what the vocabulary is on this stuff. I'm sorry, the vocabulary is on this stuff. Obviously, my phone ringing. Oh, good. Someone answered it. So make sure you know the vocabulary on this stuff. Take notes. I give like a note sheet at the beginning of the chapter. I would ask you to fill it in and just make sure you really understand what we're talking about when we say complementary versus supplementary versus congruent, and have an understanding of what those terms mean. Because if you don't, this section is very difficult. If you do, then it's so easy. So anyways, in previous lessons, you identified attributes of polygons and categorized polygons that shared various attributes, such as having the same number of sides or having one or more right angles. In the next few lessons, you will examine relationships with a single figure or diagram. Today, you will identify relationships between pairs of angles in a diagram. Then you will make and justify a conjecture. After you prove your conjecture, it will become a theorem. So, angle pair relationships. When working with diagrams in this course, you can assume that lines and segments that appear straight are straight, and you can rely on the geometric markings in a diagram. Also, you can assume that figures lie in the same plane, that is, that they have the same flat surface. However, you should assume diagrams in this course are not drawn to scale. So again, a straight line is straight, and you can count the markings that they give, but you don't get to assume that the picture is actually accurate when you look at it. Like, what I'm saying is angle ABC is not necessarily bigger than angle CBD. Now, it sure looks like CBD is bigger than ABC, but there's nothing telling you that, so you can't assume that. What you can assume is that angle ABC and CBD add up to 90 degrees. That you can assume, and you can't assume that this line is straight. All right. It says that means you will not determine unknown angle measures in a diagram by using a protractor, but rather using geometric relationships. So certain angle pair relationships come up often enough in geometry that they have special names. Oh, hold on, let me set something up. I apologize. It's referring to that I really think you should keep an eye on. So complementary angles, there's not a lot to them. Supplementary angles, we have same side interior, which is worth noting. And then congruent relationships, there's a lot of different ones. So I'll keep kind of referring back and forth to this, but this is kind of what I'm talking about. Make sure you have this thing handy and filled in. Draw pictures of these relationships so you feel comfortable with them. I think that's going to make this chapter a lot easier for you. All right, so certain angle pair relationships come up often enough in geometry they have special names. So two angles whose measures have a sum of 90 degrees are called complementary. Since angle ABD, and hopefully you remember how to name these things, right? The vertex is in the middle. B is in the middle, so it's ABD. When we say ABD, we're talking about this angle right here, is a right angle in the diagram. ABC and CBD are complementary. ABC and CBD are complementary because they add up to 90 degrees. So if angle CBD is 76 degrees, what is angle ABC? Well, what I would do is I would go over here and I'd say, all right, well, sheesh, if this whole thing is 90 degrees, which I know it is because it says right there, and it tells me that CBD is 76 degrees, well, I can use some logic. I can call this thing X, and I can say, well, I know that X plus 76 must equal 90. That makes sense, right? Because it tells me that. So then I know that's true because they're complementary angles. So X must equal 14 degrees. So that's going to be one of the relationships that I use. And again, looking at that sheet I was talking about that we want to keep handy, that's a complementary relationship. So we want to write something like angles that add up to 90 degrees, and maybe even put this example visually, draw those angles here so we know what it is that we're looking at. All right, so if the sum, I'm sorry, I want to go to this sheet. Okay, if the sum of the measures of two angles is 180 degrees, they're known as supplementary angles. So in the diagram on the right, LMN is a straight angle. And again, we know it's a straight line is a straight line. That's one thing we know is true in this book. The pair of adjacent angles, LMP and PMN, is called a straight angle pair or a linear pair. And we know that they add up to 180 degrees. That makes them supplementary angles. So again, if LMP equals 62 degrees, we'll call this angle Y. What does angle Y equal? Well, we know because of supplementary relationship, that 62 plus y is equal to 180. I can subtract 62 from each side, and y will equal 118 degrees. And you'll notice the equation that we use for complementary is different than the equation that we use for supplementary, right? Complementary adds to 90, supplementary adds to 180. So again, that's something that I would want to note over here. You'll also notice this, that there's same side interior angles, which we haven't talked about yet. So we should recognize that same side interior angles are supplementary, but it hasn't come up yet in the context, so maybe nothing to fill out, but something to kind of think about, that we're probably going to come back to this later in the lesson, or in the chapter, I should say. All right, I apologize. So it says, when two angles intersect, the angles that lie on opposite sides of the intersection are called vertical angles. So we know that these are vertical angles and these are vertical angles because they're opposite. So example, AED, this angle right here, and CEB, this angle right here, are vertical angles. Name another pair of vertical angles. Well, how about this one? And you'll notice I'll use 2 instead of 1. I'll say angle AEC and angle DEB. By the way, hopefully you remember this from integrated 1. We could have called this CEA or AEC. It doesn't matter as long as the E's in the middle, just like it's in the middle of the letters. And this could have been DEB or BED. It wouldn't matter, right? Now, we'll kind of go back over here, clean this up, and answer question D. It says, using a diagram at right, determine the angle measures of AEC, DEB, and CEB if X is 23 degrees. So a lot of things going on here. First of all, if this is 23 degrees, I know that these are supplementary angles, right? So X, I guess I should name this X. I can't call it X, I already have an X there. So let's call this angle Z. We'll call this angle Z. So I'll say 23 degrees plus angle Z is equal to 180. If I subtract 23 from both sides, I should get 147, I think. 157, 60, 70, 80. So I know that Z is 150 degrees, 57 degrees. Well, think about that. Doesn't this also make a supplementary angle? And isn't 157 plus 23 equal to 180? So this must equal 100. I'm sorry, this must equal 23 as well. And well, think about it. Now I have another supplementary angle, or it could be this one or this one, right? There's a lot of supplementary there. Long story short is this would be 157. So we already discussed the supplementary angles here, right? We already discussed these supplementary angles, but what does that say about the vertical angles? What do you notice about the vertical angles here? They appear to be congruent when they have the same angle measure. So I would go over here to my congruent angles. I would say congruent angles are equal. They have the same relationship. And then I would probably, and I don't think I can draw on this, I can't, I would probably draw a vertical angle right there just so I knew what the vertical angles look like. So again, keep this note sheet handy and be filling it out as you go. Alrighty, so 169, when angles have equal measures, they're referred to as congruent. Use your work from part D in problem 168. Which pair of angles are congruent? Well, we said AEC and DEB. What other relationships these angles have? Well, they were vertical, so we know that vertical angles are congruent. So based on your observations, write a conjecture. Again, a conjecture is a guess. I'm guessing that vertical angles, okay, I give up on this handwriting. This is ridiculous. So I'm guessing, my conjecture is that vertical angles are congruent. That's my conjecture. That's my guess. So now I'm going to go down here and try and prove that. So let me pause for a second and set this up. Oh, the interesting thing is we proved it with numbers, but that only is true for the numbers 53 and 1, or 57 and 123, or 23 and 157. I think it was 23 and 157 that we just did. That's the only time that we proved it. Now we're going to use variables, and if we use variables, then we'll prove that it's always true. It doesn't matter what it is. So let's go through this. It says, when Jacob answered part B of this problem, he said vertical angles are congruent. That was the same thing that we said. So do you think Jacob's vertical angles conjecture holds for any pair of angles? I think it probably does. That logic of supplementary angles seemed to make sense, but let's see. It says Jacob explanation included the diagrams showing the intersecting lines. He wrote that a plus b equals 180. That's true because they're supplementary angles. He said that a plus c equals 180. That's also true because they're also supplementary angles. So that makes a lot of sense. How can you use Jacob's statement in part B to prove that vertical angles are always congruent? So let's go ahead and let's take a look at what we can do with what this guy is saying. Okay, so we are going to say the following. Well, I know that if A plus B equals 180 degrees and A plus C is equal to 180 degrees, I can do a little bit of algebra here. I can subtract B from both sides, and I'll get A equals 180 minus B degrees, and I'll subtract C from both sides over here, right? I'll get A equals 180 degrees minus C. Hey, look, this equals A, this equals A, this must equal this. So we'll go over here and we'll say 180 minus B degrees is equal to 180 minus C degrees. And I will go ahead and I'll start by subtracting 180 from both sides. So I'll get negative B degrees is equal to negative C degrees. Now I'll divide both sides by -1. And I get B degrees is equal to C degrees. And there we go. We proved that vertical angles are indeed congruent. So once a conjecture is proven to be true, it is referred to as a theorem. Since you have proven that vertical angles are always congruent in part C, you have now established a conjecture to be a theorem. You can use it in the future without proving it again. So now, I guess I should say, I shouldn't have said it earlier. Now I say, hey, look, you can say vertical angles are congruent. Draw your vertical angles and say that they are equal to each other. And it's going to be important again. These relationships are super important. These add to 90, these add to 180, these are equal to each other. So as long as we recognize the relationship, then we can easily come up with the correct equation. And I'll show you what I mean by that as we continue. So here we need to look at these and decide, are these complementary, supplementary, or congruent, and then write an equation. Now, it says it wants us to solve for x here. So identify the angle pair relationship. These look to be supplementary angles, right? We have a straight line. These should add up to 180 degrees. And now let's solve. I'm going to say, well, 7x plus 3x is equal to 180. I'll solve that in a minute, but I want you to see that I have a supplementary relationship and they equal 180. Here, hey, look, this tick is the same as this tick, so these must be congruent. They must be equal to each other. I'll say 4x minus 5 is equal to 3x plus 2. This is a congruent relationship. Again, supplementary relationship means they add to 180. A congruent relationship means they are equal to each other. And this one looks like a complementary relationship, right? Hey, look, this plus this is equal to 90. So I have a complementary, actually, I'm going to leave myself a little more room. I have a complementary relationship here. Complementary. Good. That says complementary. All right, and I know that 2x minus 4 plus, right, this chunk of 2x minus 4 plus this chunk of x plus 7 is equal to 90 degrees. And what I'm going to go ahead and do is now solve these things. I'll worry about this one in a minute. Here I get 10x equals 180, combining like terms, now I'll divide by 10. X equals 18 degrees. And that makes sense, right? Because if I plug in 18 here, I get 18, 36, 54 degrees. If I plug in 18 here, I get 140 minus 14 is 126 degrees. And guess what 126 plus 54 equal? They better equal 180. So that's good. Here, if I solve these, I'll subtract 3x from both sides, and I'll add 5 to both sides. And I'm going to get x is equal to 7. So if I go over here and plug in 7, I get 28 minus 5 is 23. Well, when I plug 7 in here, I want this to equal 23 as well. 3 times 7 is 21, plus 2 is 23. And hey, there's my congruent relationship. Again, here's my supplementary relationship, they add to 180. Here's my congruent relationship, they equal each other. Here, they should equal 90. So I'll get 3x, right? 2x plus x. Negative 4 plus 7 is plus 3 is equal to 90. I'll subtract 3 from each side. I'll get 3x equals 87. I'll divide by 3. X is going to equal 29 degrees. Now, if I plug 29 into here, I should get that they add to 90. So 2 times 29 is 58, minus 4 is 54 degrees. So hopefully this will equal 36 degrees, because 54 plus 36 equals 90. 29 plus 7 does equal 36 degrees. So I've solved for x. Again, I use different relationships to do that. I need to keep these relationships clear. I need to know a complementary, a supplementary, and a congruent relationship. And again, notice that I'm going to be talking about a different supplementary relationship and a bunch of congruent relationships that we have yet to discuss. Just a preview of what's going to come. So now I look at this one. I want to solve this thing here. Well, here's what I notice, that these are supplementary, right? X plus 28 plus x should equal 180. So I'm going to have that supplementary relationship. 2x plus 28 is equal to 180. I'll subtract 28 from each side. I will get 152, I believe. I'll divide by 2. X should equal 76 degrees. If I go over here and plug in 76 degrees, I want these to add up to 180. So obviously this is 76. That's easy because it's x. This is 76 plus 28, so 86, 96, 104. And 104 plus 76 is equal to 180. At this point, I'm going to pause. I'm not sure if there's more to this video or not. There's problem 173 and 174. I don't typically do the theorem graphic organizers, and the reflection of light is a problem that I choose to skip. Usually there's enough going on with this chapter that people are kind of messed up already, but the bottom line is here that C and D would be equal to each other, and that they would also be equal to E, and they sort of go through proving that, but I will leave that for you if you're interested.